All right, we're going through the Exam 2 formula sheet. Now, this thing has Exam 1 formula sheet on it as well. I just want to talk through what's what. Okay, on the Exam 1 formula sheet up here, let's get this color right here, we have kinematics. Same three equations I'm using. This is number 2, this is number 3, this is number 4, this is number 5. The big difference here is I don't do these X naught things. Okay? They're not going to help anything, so I just get rid of them. Now the stuff down here, what he's doing down here is the steps I use for working through problems. Okay? For working through Newton's laws. He has them here, but he doesn't have them like I would do them. Okay? So you don't have anything telling you to do a free body. You don't have anything telling you to do components. Here you have your sum of the forces in the Y. Here you have your sum of the forces in the X. Here you have friction. That's what he's got all there. Here's the spring force. Now, that doesn't really show up on his test much. Of course, you all know that's a quadratic equation. So let's start talking about what's new for Exam 2. Okay, I got some really bright lights in here, and it's a little hard for me to see, so I have to get up and look. There we go. We got all of Exam 2 up here. First off, the bottom half, where all this really bad ugliness lives. Let's hit this with some brown right here. All this down here is center of mass. Mass and velocity. It's something that doesn't show up much on Dr. Ford test. The center of mass is these two. Velocity is here. And again, it doesn't show up much on a Dr. Ford test. So I'm not too worried about that right there. Okay? Now I buried this under, and I should not have buried it under. That's kind of bad of me. What we have right here is impulse equals change in momentum. That's what we have right there. And over here we have momentum. So impulse change in momentum, that's momentum. That means this has to be energy right in here. And up here, at the top up here, this is satellites. Which I just misspelled on camera, but that's okay. Newton's law of gravity right here. Newton's law of gravity is right there. Okay. Here's centripetal acceleration. Here's the velocity around a circle. And this right here is the time period for an orbit. And if I am not mistaken, that's Kepler's second law, but that doesn't matter to you guys at A&M. Okay? Now down here, what we have in the middle of the page, and let's get a nice purple pen for this one. What we have in the middle of the page down here, this is work and energy. Okay? So that's work and energy. Up here, we have work as force times distance. We're doing force cosine theta times distance. I don't know why he's using the S. Here we have work as change in kinetic energy. Okay, which is really kind of weird for me. Here's the spring energy. I don't know why he's doing work as change in kinetic energy, because it could be change in potential, we could change in spring. And that does show up on his test, so this one's just weird to me. Okay, here we have gravitational energy. I call that MGH because it's really change in height. Here's kinetic. Here he's saying no work. That's where we would do initial equals final. That's what he's doing here. And this is the power equation. Both these are actually power. Okay? It's organized by topic. In other words, the centripetal acceleration, satellites, then work in energy. We have momentum here in center of mass, which you probably wouldn't really use center of mass. Okay, so it is organized, just organized differently than what we would expect. I mean, these aren't the formulas I would use by any ways, shape, or mean. But that should make some sense out of this formula sheet and help some of you study, because now you see it and you know what's what. Hopefully you find that helpful.